Imagine if a glass of water could provide as much energy as burning an entire barrel of oil. This is the amazing future that could be made possible through the power of fusion. Fusion was introduced to the popular masses in 2004's Spider-Man 2. As Dr. Octopus puts it, it's the power of the sun in the palm of my hand. This sounds like science fiction, but since then it's become much more science than fiction. Fusion is literally the power of the sun. It's what fuels it. Fusion's when hydrogen atoms get smashed together with enough force to fuse them into a helium atom. The mass that's lost in the process is released as energy and in massive amounts. It follows Einstein's famous formula E=mc². This is what scientists want to use fusion for, its immense energy capacity. If humans could harness the power of the sun for our energy needs, we'd have all the energy we could ever want. But because positively charged hydrogen atoms naturally repel, it takes an immense amount of energy up front to fuse them. The sun is able to do this with the extreme gravity in its core. So fusion powers the sun, which leads to the first biggest problem. How do you contain the sun? Surprisingly, this is not what has held scientists back.
There are two main kinds of machines that are able to achieve fusion. The first is a magnetic confinement reactor, which uses electromagnets to squeeze plasma in a donut-shaped chamber to speed them up without touching the walls. Since they couldn't hold the sun, they figured out how to just suspend it. One example of this is the International Thermonuclear Experimental Reactor in France. The second kind is an inertial confinement reactor, which uses superpowered lasers to heat up a pellet of fuel, making it hot and dense enough to fuse. The most powerful laser in the world is used for this at the National Ignition Facility in America.
As far as the ingredients for fusion, there are a few isotopes that are easier to use than most. Deuterium and tritium are good isotopes to use because they have extra neutrons. Deuterium is abundant in the ocean, but tritium is radioactive and used in nuclear weapons. Helium-3 is a good atom to fuse with deuterium, but it's rare on Earth and mostly found on the moon. So, in the future, we could possibly harvest helium-3 on the moon or find safer ways to use tritium. But for now, deuterium is amazingly abundant and gets the job done.
The U.S. Department of Energy's Princeton Plasma Physics Laboratory is devoted to studying fusion. Their goal is to use a magnetic confinement reactor to produce 500 million watts of power for at least 400 seconds by the year 2020. China's Institute of Plasma Physics even announced in November that their fusion machine had achieved a temperature of over 100 million degrees Celsius, making it the hottest spot in our solar system for a very short time. Now we get to the real obstacle of nuclear fusion. We've done experiments and we can technically achieve fusion, but we don't have the technology to make it worth our money. It costs more energy to create fusion than it produces, which means as of now, we're wasting energy when we do the experiments. This is why the lack of financial investment is part of what's holding it back.
The only way for there to be any hope of practical nuclear fusion is if public support turns its favor and it gets more financial backing. Making the world aware of all of its benefits is the first step, and the first thing people get concerned about is safety. Current nuclear plants use fission, which is dangerous because it's the same process used in nuclear bombs. They produce lots and lots of nuclear waste, and if they melt it down, it can cause disaster. Fusion, however, is much safer. If a fusion reaction fails, the plasma expands and cools, and the reaction just stops. It creates much less waste than nuclear fission, as potential energy is so much higher.
Possibilities with fusion are endless. As students, we are interested in it because
This could determine our whole future. Figuring out fusion energy could be the most important breakthrough in our lifetime. It would be a first step towards creating clean energy and keeping the Earth livable for as long as we can. And we're getting closer. According to Stuart C. Prager from Princeton Plasma Physics Lab, we've gone from producing milliwatts in the 1970s to being able to produce a record 16 megawatts. But that's still only 65% output. Even though we are far away from getting it perfect, the potential is still there.
According to Mike Mall,
Professor of Applied Physics at Columbia University, a bottle of water has enough deuterium in it for the energy potential to be the same as burning a whole barrel of oil.
naturally, it would lessen our dependence on foreign oil, but it would lessen our dependence on fossil fuels
For the entire world, giving us a valuable step towards slowing climate change.
If it works and we develop facilities to
Harness it, we'd have all the energy we could ever need.